confident, va?
Yeah, better start it off.
We'll start it. Deepkandappa sir.
Yes, okay. Hello, and a very pleasant morning to everyone who are all part of this virtual FDP on potential research avenues in computer science, engineering, and biology. As all are aware, this virtual gathering is to give a kickstart for the same. We begin with seeking the blessings of Almighty. Ms. Pratika will render the invocation song on behalf of all of us. Please, Pratika.
Yes. Am I audible, sir?
Yes.
महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महागणपतिं मनसा स्मरामि महादेवसुतं गुरुगुहनुतं महादेवसुतं गुरुगुहनुतं मामरकोटि प्रकाशं शान्तं महाकाव्यनाटकादि प्रियम् महाकाव्यनाटकप्रियं मूषिकवाहनमोदकप्रियं महागणपतिं मनसा स्मरामि वसिष्ठवामदेवादिवन्दितमहागणपतिं
ಇನ್ನೂ 4 ಜನ ರೆಕಾರ್ಡ್ ನಾಲ್ಕು ಜನ
Please all of you mute your mic.
Yeah. It's our pleasure to have few eminent and esteemed personality witnessing this inaugural event. Let's respectfully welcome them, honorable members from the management, guests, resource persons, participants, and all others who are part of this FDP. I request Dr. A. Geetakiran Madam, Professor and Head of Computer Science and Engineering Department of our college, to deliver the welcome address, and also I request her to highlight about this FDP. Please, Madam.
Unmute.
Good morning, all. A warm welcome and pleasant morning to respected excellencies, distinguished guests, panel of experts, peers, and my colleagues. It's a true pleasure for me to welcome you all to the 5-day ATAL-sponsored Faculty Development Program on Potential Research Avenues in Computer Science and Biology. A great pleasure lies in me to welcome distinguished dignitaries for the inaugural function. Today, we have with us a great personality by himself, Dr. K. Chidananda Gowda, who has taken his time off from his busy schedule to be a part of this program and deliver the inaugural address. On behalf of my institution, I wish you a cordial welcome, sir. It's an honor for me to welcome Dr. P. Nagabhushan, Director, IIIT Allahabad, who has played a major role in planning this program. It's your support that has made us execute the program in a well-planned manner. Hearty welcome, sir. In particular, I would like to acknowledge the guidance given by my PhD guide, my guru, Dr. Murli S., President and Professor, Maharaja Institute of Technology, Mysuru, for being with me from day one in the meticulous planning of the sessions. I am indebted to you for your support, sir. A hearty welcome to you, sir. I would like to place it's my pleasant welcome to Dr. T.S. Guru, Professor and Chairman, Department of Studies in Computer Science, University of Mysore, for his continuous support and guidance. Welcome, sir. A warm welcome to Dr. M.S. Dinesh, Senior Scientist, Philips India Limited, for accepting our invitation as expert, as well as introducing his favorite guru, Dr. K.C. Chidananda Gowda. Welcome, sir. We have with us our Honorable Chairman, Sri Ashok Haranalli, who is always a great support for us and a great source of inspiration. He will be presiding the function. A warm welcome to you, sir. At the same time, I always thank him for very much for giving his valuable time. Today also is very busy. He'll be joining us around 10:50. I extend my warm welcome to distinguished members of management, Sri R.T. Yave Gowda, Secretary, MTES. Welcome, sir. Dr. D.C. Aravind, Joint Secretary, MTES, Hassel. Sri R. Sheshagiri, Treasurer, MTES, and Kamina, Manager, MTES, Hassel. I would also like to place my warm welcome to our beloved principal, Dr. C.V. Venkatesh, for encouraging us in executing any of the tasks taken up.
ఇప్పుడు
Welcome,
దీంట్లో నేను
I
మైక్ ఆఫ్
also
చేసుకోవాలంటే
welcome
అవుతుందా
our
మీట్
team
లో
planning, Dr. N.S. Jyoti, for his gracious presence. A hearty welcome to all the deans, heads of various departments, professors, and my dear colleagues. Yes, it's indeed gratifying to see so many renowned and familiar personalities as participants. Many of you have made huge efforts to join us today. On behalf of organizing committee, I
Hello.
deeply appreciate and offer the participants our most grateful welcome. I am sure the sessions over the next 5 days will be very valuable and enjoyable to everywhere. Once again, a pleasant welcome to one and all. Thank you all.
Thank you so much, madam, for your warm welcome address. I extend a warm welcome to you too to this inaugural session. So it's now time to formally inaugurate this event by watering the plant. I request the management members, Dr. N.S. Jyoti, Geeta madam, and Dr. C.V. Venkatesh sir, to inaugurate this session. I thank the dignitaries for watering the plant and formally inaugurating this FDP. So now we have the inaugural address by Dr. K. Chidanand Gowda. I think there is no need to introduce KCG, everyone knows, but still we have formal introduction. So Dr. KCG is well-known personality and former Vice Chancellor of Kuvempu University. So he will be introduced to this gathering by Dr. M.S. Dinesh. First, I'll tell about Dinesh, and followed by that, Dinesh will introduce Dr. KCG sir, and followed by that, KCG sir will address. Dr. Dinesh is a self-directed and effective professional with 19 plus years of experience in developing AI technologies for healthcare industry R&D. He has filed patents and published more than 45 plus technical research papers in machine learning, pattern recognition, and image processing area. He was adjunct professor at IIIT Allahabad and honorary professor at PET Research, Mandya, University of Mysore, India. He is mentoring doctoral students. His specialties are machine learning for medical images and text data, clinical collaborations, system architecture, computer vision, clinical studies. Now I request Dr. Dinesh MS to introduce Dr. K. Chidanand Gowda. Following that, Dr. K. Gowda will deliver the inaugural address. Please, Dinesh, sir.
Thank you. Thank you. Thanks for the opportunity. Let me introduce Professor Chidananda Gowda. Good morning, all. It's my immense pleasure to introduce my guru, Professor K. Chidananda Gowda, to the audience. So, Professor Chidananda Gowda introduced AI concept way back in 90s in India. So, Professor Chidananda Gowda done his doctoral degree from Indian Institute of Science. During his research in IISc, he introduced the concept called mutual nearest neighbor. Okay, this concept determines the high probable rate of two samples being in the same cluster. It's also derived out of the philosophy that if I am close to a person A, and if a person A is close to person B rather than to me, then that person cannot become a kind of a mutual neighbor. So this simple concept philosophy got extended, and it's introduced as a kind of a mutual nearest neighbor. And this concept was also featured in an article written by Dupes and Jane. And this is a book which is considered to be a Bible for a pattern recognition. Later, Professor moved to NASA to pursue his postdoctoral research. So NASA is a well-known, reputed space research organization. We all know, right? So there, he did research in the area of satellite image processing. And he also published the articles on similarity and dissimilarity concepts, which are quite popular among researchers even now. So then he was also a visiting professor at University of Dauphine, France, where he teamed up with Professor Edwin Dide and explored the symbolic data analysis, that concept to satellite images. See, right now, nowadays we all talk about this knowledge graphs, and then what is the way to represent the image data, right? Especially for the AI. In the AI, we need data. So data is the key. So the symbolic data gives a very good framework to represent knowledge. Now we all call it as a knowledge graph. So way back it is explored by Professor. Further, his proposal on symbolic concept on the afforestation and deforestation of Coorg area got accepted as an Indo-Dutch project. And that project, he got it to SJCE, where he converted the simple engineering college to a research organization. We are all part of that research organization. So that's where Professor planted a seed, and that has grown into a very big knowledge graph or researchers, I can say. So it's called as a Chidananda Gowda tree. We always call it as a Chidananda Gowda tree. That is not only spread within Karnataka or India, it is spread globally. Globally, US or Europe or Singapore, wherever you see, it's already spread, and people are really imparting the knowledge in the AI area. Okay. If I really and finally, he served his services to Kuempu University as a vice chancellor, and he took the university to the next level. Okay, and people say, researchers never retires. Okay, he's still imparting his gyan via Tripadis to all of us. Okay, and if I continue to talk about my professor, it's a never-ending story. It requires more than a day, and we might need a separate session to discuss his research articles. So, with the given time constraint, I will hand over to Professor. Over to you, sir. And thank you, madam. Thanks for the opportunity.
I request Dr. K. Chidananda Gowda sir to address.
Very good morning to everyone. Am I audible?
Good morning, sir. Yes, sir, you're audible, sir.
And my PPT slide is visible.
Not yet visible, sir.
Ah,
It's not visible, sir.
why PPT slide is not visible?
No, sir.
No, let me start the
You have
slide
shared
show.
the desktop, right? Yes, sir. Now it's visible, sir. You can go for the
Visible.
yes, sir. Slideshow mode, sir.
Now it is visible.
Yes, sir.
Ah, okay. So good morning to everyone. I am very happy to participate in this FDP program started by Geeta Kiran in Malnad College of Engineering, Hassan. We had a very good beginning with the invocation to Mahaganapati. So will be thinking about many of the common areas and applications with reference to biology and computers. And there is one element which is common to biology, computers, and Mahaganapati also, and that is the mouse. As you know, mouse is the mount of Mahaganapati, and the mouse is very essential for computer scientists like us, and mouse is part of biology also. So we had a very good beginning, and the other thing is that you water the plants and inaugurated this function. So that is also very meaningful because water in Mahaganapati's father Shiva himself has Ganges on his jata, and in biology and even in computers, is very essential for cooling purposes, for computer biology, for all living beings. Water is very essential. So you water the plant. I'm very happy about it. So now let us move on to biology and computer science. So for about 1 hour or so, I will be talking about potential research avenues in this area. So I will start with one quote. In many examples of computation and problem solving that are manifest in biological systems are not yet matched by digital computing systems. That is the greatness of biology and greatness of the creator of biology also. So this is the physical world from the macro to the micro. So here at the very bottom, we have all the unification, all the four forces of nature. So they are unified here: electromagnetic forces, gravitational forces, weak nuclear force, strong nuclear force. All of them have united here. So this is known as united field. And above this we have the other previous unifications. So here, and then we have the quantum level, and then the classical level or the Newtonian level, and then we are here in ICT. So information communication technology. So our computers come here, and we have the bio world above that. This is our low bio world. So this is at the top bio level, and the next to it is ICT, and then so this is we are considering we are at the Newtonian level, classical. Perhaps when quantum computers become available, so then we will jump from here to biology also. Now we will be considering only bio world, ICT, and classical level. So this is the beginning for this physical world. From macro to micro, we see where is biology and where is computers here at different levels. Biology and computer science relationships. There are three potential research avenues. One is biocomputers. So we have we are using digital computers now, but there is another biocomputers. Biocomputers built using biological materials such as DNA, proteins, etc. So a lot of research work is being done in this area also. So to do research work in this field of biocomputers, knowledge, in-depth knowledge of biology is required. In-depth knowledge of computer science is also required. And the other is bioinformatics. So storing and processing biological data and studying biological macromolecules and modeling DNA, cells, organs, etc. So when I was a vice chancellor of Kuvempu University, so there was a lot of demand for biotechnology. It was very difficult to get seats. So then I started this bioinformatics also in Kuvempu University, biotechnology and then bioinformatics. For about 10 years also, it was very, very popular course, bioinformatics. And the third one is this bio-inspired computing. So study of computations occurring in nature and using that in a problem solving through techniques of neural networks, genetic algorithms, etc. So most of our present day researchers are working in this area, say neural networks, genetic algorithms, and other algorithms. So I will be concentrating more on this bio-inspired computing, but I will be having a few slides about biocomputers, perhaps 3 or 4 slides about biocomputers and what is going on here, and bioinformatics, 1 or 2 slides here, what is going on here, and the rest will be about bio-inspired computing. In this area, a lot of computer scientists today are doing research work. So, but we should remember that there are 3 main research areas. So, considering all these 3 main research areas, I've indicated some research potential areas. So, you will see. So, like in a genetic algorithm, so it is related to the evolution of biology, and then biodegradability prediction related to biodegradation in nature. Then cellular automata, this is related to life on Earth. Then emergent systems, so this is related to ants, termites, bees, wasps, and so on. And neural networks, of course, it is related to the brain. Then artificial life, so this is related to our real life. Then artificial immune system related to the immune system of human body. And then rendering, computer graphics, this is related to patterning and rendering of animal skins, bird feathers, mollusk shells, and bacterial colonies. A Linden-Meyer system, this is related to the plant structures, how the plants are structured. And then in the mathematical, philosophical, biological foundations and ethical implications of A life. A life is artificial life. So we'll be having seeing 2-3 slides about artificial life also. Then other, it is not yet over. Communication networks and protocols related to epidemiology and the spread of diseases. Then membrane computers. This is related to intramembrane molecular processes in the living cell. And excitable media, forest fires, the Mexican wave, heart conditions, etc. Self-organization related to repair and replication. Emergent collective behaviors related to swarms. Evolutionary adaptive dynamics will be there. Autonomous adaptive and evolving robots also is another area. Then software agents, they may be either good or evil, that is another area. And synthetic artificial chemistry, biology, materials, etc. They are also related to this. And applications of this will be in finance, economics, gaming, MEMS, and so on. Then biocomputers, molecular medicine, gene therapy, drug development, waste cleanup, climate change studies, alternative energy sources, bioweapon creation, crop improvement, etc. So, lot of applications are there in this area of biology and computer science. So, it is very easy to search for problems in these areas, not much work is done. But here it is very essential that one should have a in-depth knowledge of computer science as well as biology. That's why, perhaps the study of biology is very essential for graduates of computer science also, because of the new education policy. Perhaps the students in future can study in the computer science as well as biology, so that it will help them to do research work in so many areas which I have indicated here. So people are doing some work in these areas, but a lot of possibilities exist in all these, some 30 or 40 areas I have indicated here. So first, about biocomputers. So biocomputers. So biological computation or biocomputers. This is the first slide. It refers to the use of biological materials for computations. So here we will be using DNA, proteins, viruses, bacteria, and so on, not semiconductors. Refer to the use of biological materials, computation like DNA, proteins, even viruses become useful here. Sometimes called biocomputing also. It's called biocomputing. The goal is making of biocomputers. Who knows, perhaps after a few decades, biocomputers may become very popular compared to the present day digital computers. We don't know. And bio-inspired computing need not be done on biocomputers. So bio-inspired computing now we do using our conventional digital computers. They need not be done using biocomputers, but in future perhaps it may be done. Second slide. So rapid advancement in computer technology will lose its momentum when silicon chip reaches its full capacity and miniaturization. So solving complex problems which today's supercomputers are unable to perform in stipulated period of time. So at that time, biocomputers may become very handy. Biocomputers could be a remedy to this problem. Third slide. Biological computers are computers which use synthesized biological components to store and manipulate data analogous to the processes in the human body. The result is small yet faster computer that operates with great accuracy. Main biological component used in a biological computer is DNA. So as you know, DNA stands for deoxyribonucleic acid. So it is a type of acid, and that becomes very useful. That is one of the components for biocomputers. A hereditary material found in almost all living organisms. So it is easy to get it, located inside the nucleus of a cell. Helps in long-term storage of information. Information DNA is stored as a code made of 4 chemical bases, as you know, A, T, G, and C. Order and sequence of these bases determine the kind of information stored. DNA computers are small, fast, and highly efficient computers, which includes the following properties: dense data storage, massively parallel computation. See advantages: dense data storage, massively parallel computation, extraordinary energy efficiency, very essential nowadays. So that is about the first one, biocomputers. Second one is bioinformatics, which is very much related to biotechnology. So this is the next level of biotechnology. This is bioinformatics. So there are many courses in all over India in this area, bioinformatics, like biotechnology. Bioinformatics, it is a field of science in which biology, computer science, and information technology merge into single discipline. So here also the 3 types of knowledges are required in the field of biology and in the field of computer science and then information technology. They merge into to form one discipline. Conceptualizing biology in terms of macromolecules, not micromolecules, but they consider here macromolecules, bigger in size, and then applying informatics techniques to study these molecules. It deals with the accessing, storing, processing, and managing molecular data. It uses mathematical, statistical, and computing methods for solving biological problems. So using these methods. So that is the two methods, on bioinformatics and biocomputers. So then we move on to the third class, that is the bio-inspired computing. So we'll be spending our most of the time in this area of bio-inspired computing. So can we, you can, one thought comes to us here, computers are doing biomimicry. We know mimicry, some people, it is an art, very good in mimicry. So here computers will be mimicking. So bio-inspired, so mimicking biology. That is the greatness of this, mimicking biology computers are doing here. So classical computations is good at, and it will be classical bad at. It is good at what? And classical computing is bad at what? So we will see. So classical computing or digital computer is good at number crunching, of course. Thought support, like a glorified pen and paper. It is nothing but a glorified pen and paper. Rule-based reasoning, constant repetition of well-defined actions, algorithms, So classical computing very good at all these things. But it is somewhat bad at this pattern recognition. So it is very difficult for it to recognize patterns, even speech. Robustness to damage, bad at. Dealing with vague and incomplete data. So the data is incomplete and vague. So digital computer becomes not very efficient. Adapting and improving based on experience. Here also, this is one of the weaknesses of classical computers. So good at certain things and bad at certain things. Then there is what is known as natural computation, which we find in nature, So that is what this is the computation done by the creation. We call creation as Brahma in India. So creation, that's natural computation. So in the very first slide, we saw that in a natural computation is very much superior to the computer computation which we do here. So computation occurring in nature or inspired by nature, they're occurring in nature. That is natural computation. Information processing occurs in natural systems from the DNA level up through the brain to the social level. So it is up on the DNA level and then to the brain and then to through thoughts, to the social level. So this computation is occurring. We can learn from these processes and apply them in computer science. So then it becomes what is known as bio-inspired computing. We are inspired by biology. So what computation is taking place in nature, that we are inspired by that. Here there are computer systems, devices and algorithms based more or less closely on biological systems. Biologically inspired computing, there are advantages, like they are very efficient, they are very robust, adaptive, flexible, parallel, so many advantages, decentralized, they are modular, structural stability is there, self-organizing. So this is very important, self-organizing. We can build many types of self-organizing system. It is said that the entire, some people, Einstein used to say that this universe, is a self-organizing system. So according to that, even a creator is not required. This is what Einstein used to believe, the entire universe is self-organizing. Perhaps, even a creator is not required if self-organization is taking place in the universe. And then in self-repairing also, that's another advantage. Not only organizing, self-repairing. Then self-optimizing. See how many advantages. And self-protecting, it protects itself. Biologically inspired computing. Biologically inspired computing is a major subset of natural computation which occurs in nature. Biologically inspired computing, also bio-inspired computing it is called, is a field of study that loosely knits together the subfields related to the topics of connectionism, social behavior, and emergence. So the emergence is a good concept here also. It is often closely related to the field of artificial intelligence, as many of its pursuits can be linked to machine learning. It relies heavily on the fields of biology, computer science, and mathematics. So in-depth knowledge in all the three fields is very essential: biology, computer science, and mathematics. That's why in some of the American universities nowadays, they have a separate department known as computer science and mathematics. So briefly put, it is the use of computers to model nature, simultaneously the study of nature to improve the usage of computers. So some ideas of bio-inspired computing. One is the way in which bio-inspired computing differs from traditional artificial intelligence is in how it takes a more evolutionary approach to learning. So as nature has evolved, so here also we take evolutionary approach to learning as opposed to the what could be described as creationist methods used in traditional AI. Creationist methods used in AI. In traditional AI, intelligence is often programmed from above. The programmer is the creator and makes something and imbues it with intelligence. So it comes from above. But here and it comes from below. Bio-inspired computing, on the other hand, takes a more bottom-up, decentralized approach, as in nature. Bio-inspired techniques often involve the methods of specifying a set of simple rules, a set of simple organisms which adhere to these rules, and a method of iteratively applying those rules. After several generations of rule application, it is usually the case that some form of complex behaviors arise, which could not be predicted in the beginning. So complexity gets built upon complexity. So complexity goes on increasing. Complexity gets built upon complexity until the end result is something markedly complex and quite often completely counterintuitive from what the original rules would be expected to produce. Natural evolution is a good analogy to this method. The rules of evolution. What are the rules of evolution? Like selection, recombination, reproduction, mutation, and more recently, transposition. So these are the elements. So natural evolution is a good analogy for this. Are in principle simple rules, yet over thousands of years, why thousand millions of years, have produced remarkably complex organisms. A similar technique is used in genetic algorithms. So bio-inspired networking. What is meant by bio-inspired networking? So one is introduction, then swarm intelligence. In bio-inspired networking, swarms, how do they convey information? Then artificial immune systems, cellular signaling pathways. The term bio-inspired has been introduced to demonstrate the strong relation between a particular system or algorithm which has been proposed to solve a specific problem and a biological system which follows a similar procedure or has similar capabilities. Bio-inspired computing represents a class of algorithms focusing on efficient computing, example for optimization processes and pattern recognition. Bio-inspired systems rely on system architectures for massively distributed and collaborative systems, example for distributed sensing and exploration also. Bio-inspired networking is a class of strategies for efficient and scalable networking under uncertain conditions. Example, for delay tolerant networking. The design of bio-inspired solutions will be considered now. So here we have at the bottom identification of analogies between biology and ICT, that, and then understanding modeling of realistic biological behavior, and then engineering aspects in the model simplification and tuning and so on. So the design of bio-inspired solutions, first is an identification of analogies. So what are the what is the analogy? So you can find in swarm or molecular biology and IT systems. So analogy between IT system and the swarm, birds, swarm of birds, molecular biology and IT. So analogy you will have to identify. Then you must understand computer modeling of realistic biological behavior. So, and then you can proceed. Then engineering aspects, model simplification and tuning for IT applications. So this, all these points so are indicated in this form. So identification analogies between biology ICT, understanding it, then modeling of realistic biological behavior, and then we want to engineer it, build it, model simplification and tuning for your particular applications. So these evolutionary algorithms known as EAs, Darwin proposed that popular individuals capable of reproducing and subjected to genetic variation followed by selection results in new populations of individuals increasingly more fit to their environment. That is the survival of the fittest. That is what he said. So here the classes of many classes will be there. One, genetic algorithms, then evolution strategies, evolutionary programming, genetic programming, and classifier systems. Working principles are definitions of the search space and of an initial state, evaluation of an objective function, selection of new candidate states. Examples are simulated annealing and hill climbing. There are examples. Simulated annealing also in another area. So annealing, we take from mechanical engineering, annealing. So this is simulated annealing, and then also the hill climbing. So bio-inspired research, artificial neural networks, we will not go into details, but just for the sake of completion, so I'll be indicating it. So bio-inspired research, the artificial neural networks. Artificial neural network, ANNs, primary objective of an ANN is to acquire knowledge from the environment. So that is the self-learning properties. So here, as you know, input x1, input x2, and input xn. So these are the weights. So b1, b1, and this is the summing junction will be there. So this will be the b will be the threshold, and then so this is the output of this, and then there will be activation function. So you'll have to select particular activation function depending upon the problem, and then you will be getting the output. And this is a simple diagrammatic representation of an artificial neural network. So however complex, it will be somewhat so like this only. So bio-inspired research, one is swarm intelligence. So swarms of birds and bees and honeybees and other flies, and then artificial immune system known as AIS, and cellular signaling pathways. So these are some of the areas. Some of the natural systems worth studying. So because if you study the natural system in biology, so it will be useful for us because we can do research work in the field of computer science. So adaptive path minimization by ants. Since the ants do path minimization, how do they do it? So if we understand that, it will become very useful to us. Then wasp and termite nest building. They build in a beautiful nest, such small creatures, so millions of them. How do they cooperate and do it? If you understand that, it will be very useful to us. Army ant raiding. How do they raid? So perhaps this will be useful for military. How the armies do it. ants do it. So it will be used for military. Then fish schooling and bird flocking, the fish schools of fish means so the group of fish, and bird flocking, how they move about. Pattern formation in animal coats. So how the pattern is formed in animal coats of lions and tigers and cheetahs and so on. If you understand that, so it will be very useful in computer graphics and other areas. Coordinated cooperation in slime molds in sea, synchronized firefly flashing, so how synchronization takes place there. Soft constraint satisfaction in spin glasses, evolution of natural selection, game theory and the evolution of cooperation, competition at the edge of chaos. It is useful for chaos theory, information processing in the brain. So a lot of applications. So that's why we should study all these natural things in biology. For that, a study of biology is very essential in future. Some of the artificial systems studied by the researchers are the following. Artificial neural networks, of course, all of you are familiar, and then simulated annealing, cellular automata, ant colony optimization, artificial immune systems, particle swarm optimization, genetic algorithms. So this is some of the artificial systems studied by researchers. So there are many other systems, worth studying. They may become useful. People can do a lot of research work in all these areas. Pattern recognition and optimization, they are somewhat related. These two things tend to come up a lot when we think of what we would like to be able to do with software, but usually can't do. So this is very essential. We can't do, but what do we want to do? But these are things that seems to be done very well indeed in biology. It is very, like eating a cake, very easy for nature, biology. But it is very difficult for us human beings. Why it is like that? We are not able to understand that. So it seems like a good idea to study how these things are done in biology. Example, usually how computation is done by biological machines. And pattern recognition and optimization, one more slide, I think. Pattern recognition is often called classification. Formally, a classification problem is like this. We have a set of things, yes, Example, the yes may be anything like images, videos, smells, vectors. It can be anything, speech, speaker, anything. And we have n possible classes. So then C1, C2 up to Cn. And we know that everything in yes should be labeled with precisely one of these classes of C1, C2 up to Cn. In computation terms, the problem is this. Can we design a computation process that takes a thing yes from yes and put it in input and always outputs the correct class label for yes? Is it possible? And then that is what is pattern recognition is. Pattern recognition is often called classification. Formally, a classification problem is like this. We have a set of yes, and then we have n possible classes. In computation terms, the problem is input. So this I think is already there. Then classification examples, we will consider many examples here. So what is yes, what may be in and what may be the class. For example, images of people we give, say faces. Then we will have to identify male or female. And more, then what should be the age and so on. And then smells, example, molecular spectra. So is it illicit drug? Okay, or fresh meat, good meat, rotten meat, and so on. Utterance of hello, just the utterance of hello. Then whether it is it is uttered by a child or a man or a woman or authorized person, unauthorized machine, and so on. Rendition of my signature, like whether it is genuine or fake. So signature identification. Images of artworks, beautiful, whether it is beautiful, whether it is good, whether it is reasonable, whether it is awful. And then patients' data, results of various blood tests, malignant, benign. Application for loans, at a good risk. Is there any risk? Medium risk, bad risk is there if the loan is sanctioned. Then aircraft engine diagnostics, whether it is safe, needs maintenance, ground penetrating radar images, land mine is here, for the military people is very essential, whether it is safe and so on. These are examples of some samples, yes, and the classes to which they must be sent. Points to be noted about these examples, all the above examples. The idea of this example is to remind you that pattern recognition is something you do easily as human being, and all the time. We do all the time, and as soon as we see a person, so we recognize him. As soon as we see his face, we recognize him. So even if you don't see by listening to his voice, his or her voice, you can recognize him. And we probably do it much better than we can do with classical computation. So classical computation is difficult. Remind you that such complex pattern recognition problems are not yet done well by software. Indicates that there are some very important problems that we could like to solve with the softwares are obvious, but of course we would like to do all 9 and much more, which are classification problems, and note that these are just hard examples. So hopefully, so we can learn how brains work and so on there, because there are other slides using them we will see. Now, this is how brains seem to do pattern recognition. So here on the left, you have the brain here, and here this is the cell body and our axon, and then dendrites and so on. And this is here, these are connected. The neurons are connected here. And this is the connections of millions of neurons in our brain, inside the brain. So here, the business end of this is made of lots of this joined in networks like this. Much of our own computations are performed in by this networking. So networking of this cells, and this is the network inside our brains.
So not
Brain-inspired computing is the brain is a complex tangle of neurons connected by synapses. So that is indicated, neurons connected by these, all the lines are synapses, of course. For the sake of completion, I'm just reading this because you are all familiar with this. When neurons are active, they send signals to others. So indicated by those red neurons, they send signals. A neuron with lots of strong active inputs will become active. So it will become active. And when connected neurons are active at the same time, then link between them gets stronger. So that's why when you do certain things repeatedly every day, so the link becomes stronger and stronger. So suppose these neurons happen to be active when you see a fluffy animal. Suppose these 4 red neurons. Suppose these neurons happen to be active when you see a fluffy animal with big eyes, small ears, and a pointed face. Then do you recognize it? And suppose your mother then says, when you are young, when you are 2 or 3 years old, the mother said it is a cat. It is an fluffy animal with big eyes and small ears and a pointed face. And your mother told, see dear, this is known as cat. Bekku, in Kannada we may say bekku, which excites these additional neurons. These 4 or 5 neurons, it excites them. Links will then strengthen between the active neurons. So for the cat, so when you see a similar animal again, so another cat from a neighbor's house, So when you see a similar animal again, this neuron will probably automatically be activated, helping you classify it. A slightly different group of neurons will respond to dogs, and sometimes both the cat and dog group will be active when they are together, but one will be more active than the other. And if a tiger also comes there, so then there will be the third class. Consider this in particular, what happens if we damage a single neuron. Remember, in reality, there will be thousands involved in simple classification style computations in the brain. Suppose one neuron is damaged. Compare this with damaging a line of code. What will happen if one line of code is missing? And what will happen if one neuron is missing? So this is, if the neuron is missing, it will work. But, if one code is missing, the entire algorithm won't work at all. In classical computing, we provide rules, but biology seems to learn gradually from examples. So biology learns from examples. So classical computing, we provide rules. So rule-based. How biology optimizes. We wish to design something, we want the best possible, or at least a very good design. The set S is a set of all possible designs. It's always much too large to search through the set one by one. However, we want to find good examples in S. In nature, this problem seems to be evolved wonderfully well again and again by evolution. Nature has designed millions of extremely complex machines, each almost ideal for their tasks, assuming an environment that doesn't go haywire, using evolution as the only mechanism. If you using only evolution, so it has created, our nature has created millions of living beings. Clearly, this is worth trying for solving problems in science and industry and technology. An overview of BIC, known as brain-inspired computing techniques, evolutionary algorithms, use nature's evolution mechanisms to evolve solutions to all kinds of problems. Example, to find a very aerodynamic wing design, we essentially simulate evolution of a population of wing designs. Good designs stay in the population and breed to poor designs die out. Evolution algorithms are highly successful and come in many variants. There's also a lot to learn to understand how to apply them well to new problems. Evolutionary algorithms are all about optimization. However, classification is also an optimization problem. So ES work there too. And then swarm intelligence. How do swarms of birds, fish manage to move so well as a unit? How do ants manage to find the best source of food in their environment? What is the secret? Answers to these questions have led to some very powerful new optimization methods that are different to ES. These include ant colony optimization and particle swarm optimization. Also, only by studying how real swarms work are we able to simulate realistic swarm behavior. Example, as well, this was applied in a Jurassic Park and Finding Nemo, etc. Many of those such films, So this technique was used. This is swarm intelligence, we need not to consider all them, This is how they start from this and finally they form this pattern. The emergent collective intelligence of groups of simple agents. So the ants are very, very small creatures, They initially, they are moving in random. See, slowly. So the formation, how do they form? So finally, this is formed, How do they do it, So as one above, this is one whole lot of research in this area. Ants solve complex tasks by simple local means. Ants' productivity is better than the sum of their single activities. Their group activity is better than the single activities. That's why, group work is always better. Ants are grand masters in search and exploration. They are grand masters in search and explorations. So this is in army ant. It is a picture in. So this is a in the leaf, I think, a leaf. So how many army ants are there? It will appear like this. It appears like this each end. No permanent nest for them. Create temporary bivouacs from bodies of workers. Raiding parties up to 2 lakhs, in war, with other groups of ants, raiding parties up to 2 lakhs also. How do they move? That is wonder. Act like a unified entity. All the 2 lakhs ants, act like a unified entity when they wage war. Emergence and self-organization. As I said earlier, Einstein believed in self-organization of the entire universe. So this ants do it naturally. Emergence and self-organization. So is a very important concept. Operational definition. The appearance of that which is greater than the sum of its parts. So that's what we find here in all these aspects. The appearance of that which is greater than the sum of parts. It will be 2 plus 3. So will not be 5, but it may be 7, 8, 9, and so on. Whereas if it is said that if two people work in Japan, so their output will be more than 2 because there will be a lot of harmony. But it is said that if 2 people work in India, so the total output will be half, sometimes 0.25, sometimes even 0 also, and sometimes it will become negative also. That is what they say. So that's why it is greater than sum of the parts in all these operations. You observe this. The appearance of that which is greater than the sum of the parts. 2 plus 2 will be more than 4. It may be 5, 6, 7, and so on. Example are human intelligence from artificial intelligence. Artificial intelligence is set in algorithms, whereas human intelligence is capable of transcending algorithms. So here we cannot transcend the algorithm that is used, but whereas human intelligence capable of transcending algorithms. Human intelligence and artificial intelligence can work similarly in algorithms. Human intelligence transcends algorithms. AI does not necessarily transcend its given structure. And then another concept in this field is known as emergence. So what is it, emergence? Emergence resembles the development of a complex organized system. How the complex organized system emerges. It refers to the arising of novel and coherent structures, patterns, and properties due to the self-organization going on in various complex systems. So Einstein used to say that the universe has emerged by self-organization, and no creator or Brahma is required. By self-organization, the entire universe, living and non-living things, they emerged. It is the opinion of emergence, opinion of Einstein. Self-organization is a process by which a system increases its complexity through internal organization without being guided by any external source. Without any external source, so it will organize itself. So that is a wonder. See, best example from nature is this, a termite cathedral. It looks like a beautiful cathedral. So mound produced by termite colony. So it seems its height is about 8 or 9 feet, so tall, and it is created by very small ants, termites, very small ants, billions of them. How do they cooperatively work, and how this has emerged, that is really great. So it looks like a cathedral. So this is famous termite cathedral mound. So from some country, I don't know which country. Emergence, like that. Weak emergence is there, and then strong emergence is also there. So what is weak emergence? So the emergence results from a linear combination of the system components. So linear combination. The emergence qualities are reducible to the individual components. So this is based upon Newtonian physics, Newtonian physics. So, but this is not like that. This is beyond Newtonian. Strong emergence. Wholes cannot be predicted from the parts since the combination are non-linear in this case. The emergent qualities are irreducible to the system components, system theory of physics, perhaps quantum mechanics also. Second law of thermodynamics also becomes useful here. So system tries to be more disordered over time increase the entropy. As you know, as time increases in a system, entropy increases. Entropy increases. But in human system and animal living systems, it doesn't happen like that. Entropy must be controlled. Otherwise, people will, as soon as they're born, they will die. So what is the wonder thing happening here? System tries to be more disordered over time. Increase entropy is increasing, is becomes more and more disordered. What about emergent systems? They tend to be more and more ordered over time, because when a child is born, it becomes more and more ordered. So entropy decreases actually, doesn't increase. Whereas a human system, in an electronic system, computer system, entropy increases. So a computer or a mobile works for 1, 2, or 3 years. Afterwards you can't use even an Apple mobile. Why it happens? Because the entropy increases, the disorder increases. Whereas in nature, entropy decreases. And what is the secret? If you can understand, then it is good. The micro state and emergent system is also disordered. Entropy is reduced through how it is reduced through an exchange with the environment. And so the order manifests in the macro level. Emergent systems are open systems. They're open systems, and entropy is reduced through an exchange with the environment. So that's why the environment is very essential. Even that's why it is said that trees, etc., are very essential in environment. So that people have the benefit of living. Amazing ants. Ants are successful. Why? 30% of Amazon biomass is ants. Amazon biomass, Amazon forest. 30% of the Amazon biomass is ants and termites. Just imagine the biomass. The rest are trees and other living animals, bigger animals and so on. 30% is ants and termites. Dry weight of social insects is 4 times that of other land animals in Amazon. See, dry weight of social insects is 4 times that of other land animals in Amazon, including human beings. Perhaps 10% of Earth's total biomass is because of these ants. In the entire Earth, 10% is ants. So ants are very essential, comparable to biomass of humans. Reference, you can refer the work Deborah Gordon, Ants at Work. So it was published in 1999. Intelligent behavior of harvest ants, a particular type of ants, find shortest path to food. How do they find it? Prioritize food sources based on distance and ease of access. Priority is formed. Adjust number involved in foraging based on colony size. See, such an adjustment is there, depending upon the colony size, amount of food stored, what is stored already available, amount of food in the area, presence of other colonies, etc. So they consider other colonies also. See, so wise ants. And then, of course, one slide in co-network, you are all familiar with that. Just for sake of completion, I'm indicating one slide each. There's one type of neural computation which is largely about how we can teach machines to do classification and pattern recognition. But there is more fundamental type of neural inspired method which relates to making sense of the world around us without being trained or taught. So training is not required. This is what Cohen network does. And then in another concept is cellular automata. Automata CA are very simple computation systems that produce very complex behavior, including lifelike reproduction. So lifelike reproduction. CS, cellular automatas, are also very useful for explaining, simulating biological pattern generation and other behaviors. So, and then, neural computing, one example I'm giving. Pattern recognition using neural networks is the most widely used form of biology inspired computing, BIC, biology inspired computing in industry and science. This is Stanley, the vehicle. This is Stanley, winner of the DARPA Grand Challenge. DARPA is the Defense Department of the United States of America. DARPA Grand Challenge. There was a great example of bio-inspired computing, winning over all other entries. Many other entries were there. So here they used big over other entries which were largely classical. So they used this and they won actually. This is an example for biologic inspired computing. and then artificial life. So I'm coming to the end almost. So in another 5 to 10 minutes, I think I'll be completing. Artificial life. So we are talking about artificial intelligence, but it's another area known as artificial life. Life itself is, create artificial life, but some of us make life also very artificial. So it should not be like, it should be natural life. Profound truth is, the whole is more than the sum of the parts. That is the great profound truth. The whole is more than the sum of the parts. 2 plus 2 is more than 4, 5, 6, 7, and so on. The holistic approach to artificial life were hinted at the pioneering work of John von Neumann, known as the father of computers. So it was proposed by him, John von Neumann. His approach using cellular automata, CA, were the first steps towards creating life itself, creating life artificially. The aim is to create life in a virtual medium. How to create life virtual medium? So this is what John von Neumann talked. And then computer viruses, and now we have coronaviruses, but if we had a computer viruses are closer to artificial life than anything else human beings have made. Computer viruses are closer to artificial life than anything else human beings have made. They are able to reproduce. Computer viruses they are able to reproduce like animals. So what happened? They can hide from predators, you see. Computer viruses can hide from predators. They can survive outside captivity. So let us hope that coronaviruses don't have such properties. Only computer viruses, only computers will be affected. Let's hope coronaviruses are safer than this. Then artificial life. What is the motivation for this? Why after artificial intelligence? Why should we consider artificial life? What is the motivation? A life, artificial life, could have been dubbed as yet another approach to studying intelligent life, had it not been for the emergent properties in life. So there are emergent properties in life, that's why this is studied. That motivates scientists to explore the possibility of artificially creating life and expecting the unexpected. So that is great in expecting the unexpected. An emergent property is created when something becomes more than sum of parts. That is great thing. An emergent property is created when something becomes more than the sum of the parts. A line of emergence. What you get when something is more than the sum of its parts. Human thoughts rely on nearly all cells that make up the brain. Single cells are incapable of thought. A single neuron is incapable of thought. Thought is the emergence property of these cells, millions of them coming together and interacting to give complex results. Motivation behind CA and NN, etc. So one cell is very weak, but millions of them they are doing wonders. So extreme example, Earth as one living thing, consisting of whole of nature being dynamic equilibrium. Each part is having bearing on the other. So that's why in nature, everything is essential. Even small creatures are essential. Even honeybees, they say, is essential. If they say that if honeybees, all the honeybees are killed, then there will be no agriculture after 5 years and so on. And there will be no living beings after 10 or 15 years. If all honeybees are killed, because honeybees are very essential, for the plant kingdom. So everything is very essential. We should not destroy any part of this nature because it requires for the balance of nature. That is what this is teaching us. This artificial life is teaching us. It is sending warning messages. We also find entropy here in the second law of thermodynamics. When two systems are joined together, the entropy, are known as chaos, in the combined system is greater than the sum of the individual systems. This roughly applies to all systems, including those that exchange information. Life is all about fighting against entropy. It is fighting against entropy. So human body also, it is fighting against entropy. That is, as other systems lose information to surroundings, life not only keeps hold of its information, but also increases its amount of information. So that is very essential for keeping life. So I think coming to the end, so we have considered many types of informations, knowledge, and then let us close this with one poem by famous poet T.S. Eliot. So we have considered artificial life, artificial intelligence we considered. So he talks about life, not artificial life. Where is the life we have lost in living? So we say we have lived for 10, 20, 30, 40, 70, 80, 90, 100 years. But where is the real life therein? So he's asking the question, this poet, where is the life we have lost in living? And where is the wisdom we have lost in knowledge? Where is the wisdom we have lost in knowledge? So we say, knowledge systems are there, but where is the wisdom there? Because wisdom is very essential. Where is the knowledge we have lost in information? So where is the knowledge we have lost in information? The sea of information, but where is the knowledge? Knowledge is lost. If knowledge is lost, where is the wisdom? If there is no wisdom, where is life? He's asking many questions. The cycles of heaven in 20 centuries, he says, T.S. Eliot, the cycles of heaven in 20 centuries bring us farther from God and nearer to dusk. Bring us farther from God and nearer to dusk. So he says, that we'll have to think about this and so on. So I sincerely thank you for your patient listening. I thank Dr. Geeta Kiran for giving this opportunity to make a presentation before you. I sincerely thank the chairman and the management of Malnad College of Engineering, Hassan, which I have visited many times. I think perhaps some 20, 25 times I might have visited MC Hassan. I'm very happy to be associated in this presentation for the benefit of staff of MC Hassan. So these are some of the references I have used when John Hagelin Unified Field Chart of the World, Marsh University, USA, Bruce, biological inspired computations, Slake, Gary Williams, the computational beauty of nature, MIT Press, and Google searches and so on. These are some of the things I used. So finally, that the flag of India and Karnataka fly very high. So here we have the biology, and here we have the computers. All these are biological things, and these are mechanical things, computer things. So we have seen some of the things that are common and what are the research areas in this. So let the future researchers do work in these areas, and so that the flag of India flies high, the flag of Karnataka also flies high. So thank you very much.
Dr. K. Chidananda in his inspiring and informative inaugural address, has thrown light on the relationship between biology and computer science. He has taken reference of the life of ants and termites, and he has clearly explained the relationship which exactly suited the context that is related to the FDP. He has told much information which will be inspiring for the participants. So on behalf of all of us, I wholeheartedly thank you, Chidananda Gowda sir. Thank you, sir.
Sir, I think Dinesh sir wants to talk.
Yes.
Yeah, I think it's good. Professor kind of summarized the talk, madam. I think thanks for the nice presentation, Professor. And it's really good. Like as I said, Professor KCG really touched on some of the basics of neural networks, and now we call it as a deep neural networks. Okay. So all the time you rig up a deep neural network based on CNN, and we come up with a kind of segmentation, classification. So if you really go deep into it, what is there in that CNN and other stuff? So that is where this artificial neurons, right? So that is what Professor touched. So basic elements of the neural network also, and as Professor mentioned, the swarm intelligence is the way. So it is just like if you have set of network, it is not enough. How do you really build intelligence into it? How do you learn? How do you train? So what are the strong neurons? So those are the things what Professor has really touched on it. Thank you. That was a very inspiring talk, Professor. Thank you very much.
Yeah, thank you, Dr. Dinesh, for summarizing Chidananda Gowda sir's speech. So our Honorable Chairman, Shri Ashok Harnali sir, has just joined the meeting. On behalf of all of us, I extend a warm welcome to him. So now we have addressed by our eminent personalities. So we have first Dr. P. Nagabhushan sir. It's my pleasure to introduce Dr. P. Nagabhushan sir to this inaugural function, and he is such a valuable person that it may take a complete day or two, or it may require an FDP to highlight about his achievements, because he has vast knowledge about almost all the fields of computer science and engineering. But here is an attempt to briefly tell about his achievements. So Dr. P. Nagabhushan sir is currently the director, IIIT Allahabad Prayagraj since May 2017. Professor in Computer Science and Engineering since 1994 at SJCE Mysore and since 1996 at University of Mysore. University Nodal Contact Global Initiative for Academic Networking. Academic of Reformation Committee, University of Mysore. Mentor specialized program in design, creative arts, Tibetan studies conducted at specified centers of University of Mysore. Formerly, he was Mentor Director, IIIT Lucknow, May 2017 to July 2019. Chief Nodal Officer, Choice-Based Credit Pattern Continuous Assessment Education System, University of Mysore, Mysore. Director, Planning, Monitoring and Evaluation Board. Dean, Faculty of Science and Technology. Director, Center for Information Science and Technology, University of Mysore, Mysore. Also, Distinguished Professor and Chairman, Amrita Vishwavidyapeetham, Amrita University, Coimbatore. Director, Bangalore Educational Society for Technology Advancement and Research. Principal, Bangalore Technological Institute, Bangalore. And also visiting and invited professors to many foreign universities based in the United States, France, Japan, and many more. So he has guided 31 plus PhDs and 537 plus papers in national and international journals, conferences in his credits, and he has also published 5 books. This is the brief presentation. So I request Dr. P. Nagabhushan sir to share his thoughts about this FDP. Please, sir.
So good morning to all of you. I was in the wonderland of listening to Professor K. Chidananda Gowda. I was just imagining the amount of patience he had and the amount of enthusiasm and interest that even today he has in preparing so very specifically for a very wonderful FDP such as computers and biology. In fact, I was requesting Dr. Geeta Kiran to relieve me for 2 reasons. Number one, computers and biology, putting them together was such a great problem. And number 2, it is always difficult to speak after Professor K. Chidananda Gowda would have spoken. And therefore, that was the main reason why I was asking Dr. Geeta Kiran to relieve me on this day. But still, she insisted that I have got to speak. Well then, when people were listening to Professor Chidananda Gowda, I am sure most of you are teachers and most of you are from the learning community. Therefore, when you were listening to Professor K. Chidananda Gowda, you were listening with utmost care, and you were also listening because you were enjoying listening to him, and you were enjoying because you were learning the system. See, the learning and the enjoying will always resonate together. That's the reason why I draw your attention, particularly all of you are great teachers, why I draw your particular attention to the new national education policy, which clearly emphasizes that learning has got to be in the forefront. Now imagine if Dr. Geeta Kiran would have told you that you have got to take an examination, you have got to take a test after Professor K. Chidanand Gowda's lecture, that instead of listening to him with your open eyes, with your open heart, with your open brain, you would have constrained yourself what could be a good question from slide number 1, what can be expected from slide number 2, what can be expected from slide number 3, and this cannot be a question, this shall be a question. So we would have gone into these aspects. Unfortunately, over all these 70 years in India, we have been doing the same mistake, that learning is not for real learning and enhancing the knowledge. Learning is only for the stupid examination. That is what has been happening in all over these 70 years. In fact, Dr. Professor K. Chidanand Gowda concluded his lecture with Professor Eliot's, Dr. Eliot's poem. It was very interesting. Where is the life? Life is lost in the living. And where is learning? Learning is just lost in the expectation of examination. Unfortunately, that should not happen. I'm very proud that at least now, after 70 years, for the first time, India has been able to realize that learning has got to happen, because learning is the reason for great living, and great living is the reason for great life, and learning has got to happen. And that is where wonderfully the Commission National Education Policy, which was interesting, very interesting point is, this was headed by, not by a conventional professor, not like me or not even like Professor K. Chidanand Gowda or like anybody. It has been headed by Dr. Kasturi Rangan. Very interesting, you have got to observe that. Dr. Kasturi Rangan is a man of space, and a person who is able to separate himself out of his own profession and look at that profession from being an outsider, gives much inside story about the profession. Therefore, he is a man from space, and sitting in the space, he was able to look at the entire education field, and he was able to tell that this is the way in which the education field has got to continue. I'm very afraid whether a professor would have chaired this whole national education policy. I'm very afraid whether it could have come out so openly that learning has got to be in the forefront. See, the whole 1 hour, how you were mesmerized when Professor K. Chidanand Gowda was delivering the lecture. In fact, he was delivering the lecture, but he was making us to learn a lot more interesting flexibility. And he made it feel so much that biology has been the foundation for entire computing, and computing is a greater inspiration to bring biology into our life, which we have enjoyed because we were listening and we were not afraid of any examination. Okay, now that's the way national education policy very strongly recommends that it has got to be formative assessment, not the examination oriented assessment. And in fact, you remember what were we doing when we were students? We were all trying to collect the old question papers on day number 1 of the semester, all old question papers, and try to make a statistics of the old question. We were all very experts in data mining. We had lost our life in living because we were experts in data mining to find out what is the knowledge. Never we rose to the level of wisdom. We had the excellent knowledge of what type of questions could get repeated, and over time we would learn even about the professor, and we would expect what type of questions would he be able to set in the examination. So we were all good, but we never learned what the subject has got to be. Now, at least now, all teachers, young teachers, particularly teachers of your age group, has got to be very progressive in really understanding what is really formative assessment, what is continuous assessment. It is not just to load the syllabus and to show that we have been teaching quite a lot, but make it minimum, absolutely no problem, but let the people learn. What is learning? Learning is internalizing. What Professor K. Chidanand Gowda has shown through several slides, learning is internalizing. What is internalizing? Internalizing is inculcating. What is inculcating? Inculcating is putting that knowledge into action so that the action really leaves the plethora of wisdom upon every one of us. I'm very sure Professor Kechidan Gowda's lecture was so very efficient in bridging biology and computers. In fact, right from day number one, I was very afraid because these, computers and biology, linking them together would really be a difficult task. I was wondering, but how smoothly Professor K.T. Narnoda could do it and how smoothly all of us could understand that. I'm very sure assessment has got to be how well we have internalized, not what we remember, or not what we have just been able to memorize the lectures. Okay, so it is not memory which is important, which is again inculcation. And only this particular point, I'm very proud of the national education policy, that the national education policy strongly tells that it should not be examination oriented learning, or it should not be fear oriented learning. For a very, very simple example, I'm sure many of you would be very able young ladies, young lady professionals. Unfortunately, in our days, the boy used to come to our house to see a girl, or girl had got to be shown to a boy. All right. Under that fear that a boy is coming to examine me, under that fear, the girl would have got opened up. She would never have got opened up. All right. And that, in fact, that is the unfortunate part of it. We always felt that girls will never open up like that. But after the marriage, we never opened up. That is the problem. That is the only interesting. They opened up. We never opened up. Okay. Oh, well then, on the other hand, if you were to meet a boy on a very casual circumstance, like accidentally near a cinema theater, or like somebody would introduce you to a boy, how well will you discuss? How well will you exchange the information? You would so much exchange the information, so comfortably you would exchange the information, whereas on the day, on contrast, on the day when a boy were to come to your house, you would totally be sulking. You would be totally be, it is rather a depression rather than it is a emergence, like Professor Chidanand Gowda mentioned. It is not emergence, it is counter emergence. Because in the second one, you are being examined always affects you. In the first one, you are learning about somebody, you are understanding somebody, you are trying to know about somebody, is the one which makes us learn. I'm sure that is what is the expectation of biology, because biology always believes, like Professor Chidanand Gowda has also mentioned, the Darwin's theory always believes in evolution. Evolution is not examination. In evolution, the feedback is automatically incorporated and it evolves over time. So also let our wisdom also get evolved. Let our brains be open enough. Let us start learning using our heart, not using our brain. Brain will be operational in learning if examination becomes the constraint, if examination becomes the end point. If examination becomes the end point, brain becomes active. If examination is not the end point, heart opens up and a lot of things can be learned. And that's the beauty of natural resonance, the biological resonance. Thank you very much for such a small time that I could get. I'm very proud, Dr. Geeta Kiran from Malnad College of Engineering has been doing a wonderful work. I'm very happy about Malnad College of Engineering. I also recollect those good old days when Professor T.H. Chidanand Gowda and myself, we used to come to Malnad College of Engineering. Professor M.G. Venkatesh Murthy was still in the formative stage. He was doing his PhD at that time, and he still had not come back to Malnad College of Engineering. That was the time we both used to come over there. I know Professor Neil Kantappa. Now Neil Kantappa is professor at that time, a very young boy. I know from those days, so the things have been so wonderful. I'm very happy the corner, a very interesting corner from Karnataka has been ruling over the whole video today in entire India. Thanks for the learning environment which has been created in a very new field, very, very admiringly wonderful field of hybridizing both computers and biology. Have a nice time, great time to come.
Dr. P. Nagbhushan has given a wonderful presentation about the context, and also has given a humorous touch to his speech, so to wake up all of you. So now we have Dr. S. Murali. So I feel it's my honor to introduce Dr. Murali sir to the gathering. So Dr. Murali sir is currently the professor in computer science and engineering and the president MIT Mysore. He has 30 plus years of teaching experience. He has guided 9 PhD students and currently guiding 5 PhD students. So I'm happy to say that Dr. A. Geeta Kiran Madam, our beloved HOD, is one among these students. So she always speaks very high of Dr. Murali sir for his excellent guidance during her PhD. So we are happy to have you here with us, sir. So Dr. Murali sir has huge number of publications in national, international journals and conferences in his credits, and he has few patents also into his credits. So now I request Dr. Murali sir to share his thoughts about the workshop. Sir, please.
ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಟು ಆಲ್ ಆಫ್ ಯು. ಎಲ್ಲರಿಗೂ ಪ್ರೀತಿಪೂರ್ವಕ ನಮಸ್ಕಾರಗಳು. ನನ್ನ ವಾಯ್ಸ್ ಕೇಳಿಸ್ತಾ ಇದೆ ಅನ್ಸ್ಕೊಂಡಿದ್ದೀನಿ. ಕೇಳಿಸ್ತಾ ಇದೆ? ಓಕೆ. ಎಲ್ಲರಿಗೂ ಪ್ರೀತಿಪೂರ್ವಕ ನಮಸ್ಕಾರಗಳು. ಫಸ್ಟ್ ಆಫ್ ಆಲ್, ಕಂಗ್ರ್ಯಾಚುಲೇಷನ್ಸ್ ಟು Dr. Geeta Kiran and his team for conducting such a wonderful program. In fact, when she asked me, actually, I need to conduct this program in a different way. We chalked out in a different way, but maybe in the next time she would be able to execute that. But she told me that actually I need to deliver a lecture. I said very clearly no when Professor Chidanand Gowda and Professor Nagbhushan are talking. My words and my speech will not be, such a wonderful thing. So then I said, I'll be just speaking for a while. And as she mentioned, I'll be there for the entire week sessions, all the day I'll be present, I'll be attending. I recall the days, in fact, I never felt this is a different kind of program we had 20 years before actually. 20 years before, 25 years before, we used to have similar kind of programs at Mandya. Same set of people, Professor Nagbhushan, Chidanand Gowda, Dinesh, Guru. In fact, maybe others will be joining, but it's a very similar kind of team. So the beauty of the team is actually, as Dinesh mentioned, Bhishmacharya we call, Chidanand Gowda. Actually, his tree is not been broken. Actually, it is still continuing. Lot many people are still joining. 20 years before, how the program used to be conducted in a very similar, in a similar hierarchy only it is being conducted. Professor Nagbhushan should be there all the time. Professor Chidanand Gowda should be there all the time. Then only it is called as workshop. So that is how the trend has been created in this area. So that is the beauty of the relationship between students and teacher. So that is what we got to learn. Keep away the subjects. At least we got to take away this message saying that 25 years also the similar people will be there for taking up the task. So that is the speciality of the team. In fact, I always say when we have hammer in our hand, everything looks nail. So that is the usual words that we hear. So I mean, look at any area for that matter, maybe automobile, maybe agriculture, maybe mechanical, maybe civil and all. When we have hammer, actually all the everything looks like nail. Similarly in all these aspects, everywhere the computer science is being implemented. You may be thinking that just using of computer is actually implementation of computer science. It is not so. It is algorithms which runs as a supportive system for all those. For example, in today's Geeta Kiran Madam has taken very interesting, and Professor Chidanand Gowda has highlighted about the relationship between biology and computer science. It is not just mere use of computers. It is algorithms that we got to use, data analytics we are supposed to do, and use of neural networks or any kind of tool, memory mechanism, all these things are to be incorporated. It is not just using computers, it is algorithms which runs for those people actually. So that is why I said, for example, the very much the video that we are doing it over here is being tested, being algorithmically being tested by a lot of other maybe through Microsoft Meet or Zoom or whatever it is. So therefore, so this itself is a very big contribution from computer science. So therefore, we are contributing not only to our own domain, we are contributing to other areas also. Very interestingly, the biology in which today topics are being discussed, maybe computational neuroscience, evolutionary biology, or neuropsychiatry, maybe computational anatomy or computational genomics. In all these areas, actually, the computers are being used. Computer-based algorithms are being used, to support them. Understand biological systems based on approaches derived from computer science, physics, mathematics, chemistry, biology, and all this, are very much essential and unique position as a leader. So when we look at all these domains, we obviously become leaders because we give support to all this. Focus on specific diseases affecting large sections of populations such as cancer, infectious diseases. Like even in the in the pandemic situation, we have seen a lot of researchers have been developed by using algorithms and data analytics, which is basically a computer science discipline. Generate agriculture advances in developing new models and methods, in which actually I know that Dr. Geeta Kiran is working on this specific reason. It is not on human system, lot of agriculture also in which we got to jump in. It is not just enough actually. The areas in which we are all working, maybe biology, history, economics and all. Apart from that, actually we need to look at this agriculture in which we need to give our inputs. So in nutshell, it is not in this area in which the specific course is being offered. Now 1 week course is being offered on computational and of course with biology. It is not only on this. We need to spread across in all other aspects. Of course, computers are there everywhere, but we got to jump into developing newer algorithms which supports, which helps them to do their research in a better way with our data analytics, with our database management, with our artificial intelligence. All this area Dr. Chidanand Gowda has mentioned, the use of all those things and come out with as a universal research, and we would be the tree, we would be the roots for all of them actually. You name any field, for all of them, the computer science must be the root for all of them. So that is how our system should be evolved, and we have been evolving and we have been doing it, and all these things are happening only because of the kind of programs being organized, and through the learning these things will happen. And I congratulate the team again for making such a wonderful program, including all of us, including Professor Nagush and K. Chidanand Gowda, Dinesh, Guru and all. So such is the kind of beauty of this program. Congratulations to you, madam, and for the participants. You'll have a wonderful session, and I will also be witnessing this program. And thank you very much for giving me time.
Yes, Dr. Murli sir has also added few more points to the context, and he has given significant information about the research and related to the topic. And he has also admired the coordination, the teamwork since a long time working towards technological success. So it was a wonderful presentation, sir. On behalf of all of us, I wholeheartedly thank you, sir. So now it's my pleasure to introduce Dr. Guru sir to the gathering. So who's going to address you now? Dr. Guru sir is the professor and chairman, Department of Studies in Computer Science, University of Mysore, currently. Formerly was the chairman of Administration Reformation Committee, University of Mysore, Department of Studies in Computer Science, Manasa Gangotri, Board of Studies in Computer Science, University of Mysore. Also, Senior Research Scientist, NIMO Technologies, Bangalore, Directorate of Distant Education, University of Mysore, Internal Quality Assurance Cell of University of Mysore, and candidates and currently supervising 6 PhD students, published 80 plus journal and 280 plus conference papers, right now having H-index 22, have been a reviewer for many journals including IEEE Transactions and Elsevier Science, edited 5 books, 2 issues of International Journal of Machine Intelligence, 3 issues of Springer, LNNS, LNEE, and authored 3 textbooks. It's our privilege to have you here with us today, sir. So please, sir, Guru sir.
Good morning, everyone. I hope I'm audible. So I feel it's my great pleasure to be associated with this 5 days FDP program being organized by Professor Geeta Kiran. So I have nothing to speak, after having heard of Professor K. Chidananda Gowda's inaugural address, which has covered up a lot in connection with biology and computers, and followed by a wonderful dareness speech by Professor P. Nagbhushan, who really instructed us how to behave, how to take up the learning, especially for the budding technocrats, faculty members. I must thank specifically Dr. Geeta Kiran, who really made it possible for us to recollect our olden days, as Dr. Murali rightly pointed out. And we don't see any big difference, except that earlier we used to meet physically, but now we are on virtual meeting. And we are seeing the same faces. It appears to be a old wine in a new.
New presidential remarks.
Probably as days goes, get along with the changes, and especially because of this COVID. It is really tough to organize seminars and specifically today webinars, and in spite of it, Dr. Geeta Kiran and our team members have really put in great efforts to make this event possible today, inaugurated by a great scientist a philosopher, Professor K. Chidananda Gowda. So he has done a wonderful justice to this inaugural function, and having heard of his lecture, probably we, the budding technocrats, have got many opening issues for further research. So how to exploit the beauty of computational technology and of making AI in realistic, in real environment possible, and so on. And as for the advice of Professor P. Nagbhushan, we have to be very serious in taking up a learning aspects. We should not focus our attention only on somebody is examining our learning. Instead of that, we should have our own self, examination, so that am I really learning? Does that learning really lead to some contribution later for the betterment of the society? So probably I still remember when I wanted to pursue my PhD with Professor Nagbhushan, he has directed me to go and talk to Professor M.G. Venkatesh, who at the time was the principal of Malnad College of Engineering. I visited Malnad Engineering College first time before I started my PhD. While doing my initial courses, so I went to him and spoke with him, and having heard of his presentation, perhaps discussion with him, he really motivated Venkatesh Murthy, MGV, Professor MGV really motivated me to be serious in research. So indeed, I was scared of talking to him initially, and having heard of many interesting attributes of Professor MGV, and he was so strict and contributes and very serious in learning. So with that, a fear of, I just went to his office and spoke to him and personally, and then really learned a lot. Within 5 to 10 minutes, I made up my mind. Yeah, I must do good research. I must publish in international reputed journals. He specifically directly told me that, Guru, don't go with PhD. What do you do with that PhD degree unless you gain some name because of your good publication during your PhD period? That words I still remember, and in fact, the words given by such great people who probably inspired us. And Professor Nagbhushan created such an environment, and still he is involved in establishing good ambience for academic learning environment. And we should, the youngsters should learn a lot from these two great people, Professor Chidananda Gowda and Professor Nagbhushan, and they are supposed to be the role model. So I just take up this opportunity to congratulate Professor Geeta Kiran for our team members, because it's very tough to find people who are really well versed with the technology and also are known for contribution in the field of biology and computers. And I understood, looking at the effort of Geeta Kiran while finding out, fixing up the resource people. She really did a lot. She shared a couple of her communications with the resource people, and she was in a couple of uncomfortable situation. In spite of all, today she and her team members have made it possible, and it has been inaugurated by the right person with a wonderful inaugural lecture. And it will thank all the workers contribution a betterment. I thank one and all. Thanks for this opportunity.
Yes, Dr. Guru sir has shared his thoughts about this FDP, recalling a lot of his old memories and mentioning about inspiring personalities like Chidanand Gowda sir, Navbhushan sir, Murli sir, Dr. M.G. Venkatesh Murthy sir and all. So on behalf of all of us, thank you sir for your words. So now we have the presidential remarks by Dr. N.S. Jyoti of our college, so Dean Administration. Jyoti sir.
So you're muted, sir. Jyoti sir.
I'm very muted. No, I unmuted.
No, sir.
Yeah, now it's audible.
Now it's audible. Now
Yeah.
you are audible.
Okay. Thank you. Very good morning to all of you, respected Honorable Sri ATAL, Dr. Chidanand Gowda, Dr. Nagabhushan, Dr. Murali, Dr. Dinesh, Dr. Guru, and our principal, Dr. C.V. Venkatesh, and all the eminent speakers and resource persons of this faculty development program. Participants. I thank Dr. Geeta Kiran and Department of Computer Science for organizing this wonderful ATAL Academy FDP. AICTE Training and Learning Academy started with a vision. Faculty of higher education such as access it identified this program of AICTE. We are proud to conduct such a program from our institute. Coming to computer science and Professor Chidanand Gowda pointed in his inaugural talk. What is lifelong learning? Computational technology is the combined application of maths and computers. Examples are genetic mapping, protein classification, comparative long-time simulation of protein molecules, computational neuroscience, pharmacology. There are a lot many. I have noticed that this FDP have very eminent resource persons, and all the participants to make know their deliberations and wish you all.
Thank you, sir, for the presidential remarks. We have come to the end of this inaugural session of this FDP. I request Dr. R.K. Bharati Madam, Professor SGC Mysore, to deliver a vote of thanks.
Good morning, one and all. Gratitude is the memory of the heart. Today, I am overwhelmed to render the vote of thanks for the inaugural function of AICTE ATAL-sponsored one-week FDP on potential research avenues in computer science and biology. Today, we are blessed by the eminent researchers, profound teachers, humbled human beings, the inspiring forces in this function, and especially me to be amongst all my gurus over here. Success isn't just about what we accomplish in our life. It's about what you inspire others to do. Dr. K. Chidanand Gowda is one such person who has inspired a great deal of people combining technology with philosophy. He is referred to as father of symbolic data analysis and is an asset to the field of computer science and engineering. Sir, we are inspired by what you are there and here. Thanks for accepting the invitation and giving the inaugural talk, sir. We have with us a great researcher, teacher, mentor, director, Indian Institute of Technology, Allahabad, Dr. P. Nagabhushan, sir, whose contribution is immense in the field of computer science. Sir, we are very grateful to have you in this function. Thank you very much, sir. I also extend my thanks to Dr. Murli, founder president, Maharaja Institute of Technology, Mysore, who is a great inspirer and ever-acting person in various dimensions of research, entrepreneurship, philosophical thoughts. Sir, thank you very much for addressing the gathering. I extend my thanks to my another guru, Dr. Guru, Professor and Chairman, Department of Computer Science, University of Mysore, who is so synonymous to his name and seconded by all his students. Sir, thanks for being the part of this function and addressing the gathering. Our heartfelt thanks to the divine driving force support system, ever encouraging Sri Ashok Harnalli, sir, Chairman, MTS Hassan, for giving his blessings to this function. Special thanks to the Dr. N.S. Jyoti, sir, for the special presidential remarks, Dean, Malnad College of Engineering, Hassan. Sir, thank you very much, sir. Further, we are grateful and thankful to R.T. Dyavegowda, Secretary, Sri R. Sheshadri, Treasurer, and Dr. C.V. Venkatesh, Principal of Malnad College of Engineering, Hassan, for all the support extended in the conduction of this workshop and being the part of this inaugural function. Very special thanks to Dr. Dinesh, Senior Scientist, Philips India Limited, Bangalore, to accept the invitation to be the part of this inaugural function and introduce the guests. I cannot thank everyone enough for their involvement and their willingness to take on the completion of task in organizing this workshop, and hence my heartfelt thanks to the entire team of Department of Computer Science, Malnad College of Engineering, Hassan, and especially Dr. Geeta Kiran, ever active and driving force in organizing this workshop and be the part of this function. I extend my thanks to Professor Neelkantappa sir for rendering the Master of Ceremony and introducing the guests. Special thanks from my side for the MCE management, AICTE ATAL, teaching and non-teaching staff of Department of Computer Science and Engineering for their support in organizing this function. I have a special thanks to all the resource persons who will be delivering lectures on different schedules and the registered participants who will be with us for the entire week in accomplishing the knowledge. I extend my thanks for the media and press people for covering this program. Last but not the least, my special thanks for the tools and technology which has helped us to be the part of this function from our own place, covering all parts of India. Thank you one and all.
Thanks.
Yes, Dr. Geeta Kiran.
What is next?
Yes, sir. We are at the end of the program, sir.
Yes. So the next one will commence at 11:35, 40.
Yes, sir. Sir, mugito, bega bani.
You may have to. You may have to share.
Next
You may have to
session.
share the link for the session.
One second, sir. One second. 1 second. Sir.
Participants stay here or in a different link?
Hello. Hello. इसी में करना है बोर्डिंग में कुछ
Is it the same or is it?
We have another link, sir.
Yeah, we have got into that link.
Yes, sir. Yes, sir. We'll join back in another. How many minutes you need, sir?
5 minutes.
5 minutes. Okay, sir. I request all the participants to be back up to 5 minutes.
I will be putting off here. Okay.
Yes, sir. Yes, sir. Okay, sir. Thank you, sir.
Thank you.
Thank you all, sir. Thank you all for being part of this inaugural function. Thank you, sir. We'll again join back with other link to the next session. Thank you.